Alright, so this is a practice assignment 9, part 2, number 7. It involves, we're having to add and subtract some fractions here. So I'm going to spend some time going over it. And I got my 4th period class in here, very smart group. Everyone said, hey. Hey. That was a long hey, but that's okay. All right, so here we go. We've got these two equations, and you're having to solve these equations using elimination. Because you have to be able to do it all 3 ways, but you know, different practice assignments has different requirements, so you can practice each way. This one is elimination. So the very first question I'm going to ask my class, and don't shout it out, just raise your hand, is it going to be easier for me to eliminate the y variables or the x variables? Raise your hand, don't shout it out. Let me call on someone in here. Let's go with London. What do you think? The y variables, that's right, because they both have the same coefficient of 1, which means that if I can make one of them a negative 1y, well then they would eliminate each other. So, Jasmine, how can I, if I'm going to look at the second equation, how can I make that have a negative 1y? How can I make it be a negative 1y? Yes, I multiply the whole equation by negative 1. Great job, Jasmine. So I'm going to take negative 1 and I'm going to multiply using the distribution property you learned in 7th grade. Negative 1 times 1y is going to be a negative 1y. And then equals, and a negative 1 times a negative x is going to be a, what? Yes, good job, guys. A positive 1x. Now, I don't have to put those 1s there, but I'm doing it anyway just so that whenever I combine, you can see what the coefficient is easily. All right, so now I'm going to take that second equation. I'm going to rewrite it right below it. So I've got a positive 1y equals a negative 3 over 2x plus 3. And then I'm going to combine these two equations. I'm going to pick a different color. Let's go with blue. Hey, class, what happens when I combine these guys right here? Yeah, they cancel out. That's right. So they're going to equal 0. All right, so now this next part right here, this is the part right here that a lot of students are going to have issues with or shy away or they act like they forget. So what I'm going to do is I'm going to solve this using a way that most likely you learned in 6th grade. This is how a lot of 6th grade teachers teach how to add and subtract fractions. We set up equivalent fractions. So we've got a negative 3 over 2x, and this is a positive. How do I turn that 1 into a fraction, guys? Yeah, good job, Victoria. I'm going to put it over 1. And let's see. Now I'm completely set up. So whenever you're adding or subtracting fractions, you have to have a common denominator. And so what you ask yourself is, what's a number that 2 and 1 will both go into? What do you think, Jessica? What's a common denominator for 1 and 2? 2. Good job. You should see their face whenever I call on them. They're like, oh my gosh, I can't believe you called on me. All right. So now this is what you do. You say 2 times 1 will give me 2. Therefore, I'm going to multiply 3 times 1, and it's going to give me 3. So you see that this fraction didn't change at all, and I just brought over that negative sign because it's a negative 3/2. Now this first fraction is going to change. 1 times 2 is going to equal 2. Therefore, I have to multiply the numerator times 2. 1 times 2 is also going to equal 2. So there we go. I've got my equivalent fractions with common denominators. Now, you learned in 7th grade that if your signs are different and you're combining, that means you're going to subtract. So I'm going to subtract my numerators. 3 minus 2, what is it, Ashton? Yeah, 3 minus 2 is 1. Good. And then my common denominator just stays common. It's going to stay as a 2. Now, here's the question. I want someone to raise their hand. Should this be a positive 1/2 x or a negative 1/2 x? Let's go with Alexis. What do you think? Negative. Why, Sydney? I think I know what you're talking about. Maybe someone explain it in a different way. Vince. That's it. There's more negatives. Good job, Vince. Yeah, you guys had a good 7th grade math teacher. So, we've got negative 1/2 x plus 3. Someone raise your hand and tell me, what am I going to do next? I'll give you a hint. I want all my variables on one side and all my numbers on the other. What do you think, Isaiah? What's something I can do? That's okay. So just listen for the reply. Let's go over to Kyle. I wouldn't add 3 to both sides. I think that the word that Isaiah was looking for was inverse operation. We are going to use the inverse. Let's go to London. What can I do here? Yes, I could subtract 3 from both sides. Yep, that's a route I can take. And so now I've got negative 3 equals negative 1/2 x. Alright, so the very last thing I'm going to do here, what do you think, Alyssa? No, I don't have to add a 0 anywhere. I am going to divide. What am I going to divide by? Not by a negative 3. Think about this. I want to get x by itself. Yes, I'm going to divide by a negative 1/2 because that's the opposite of multiplying by a negative 1/2. Good job. Alright, so now I'm going to divide this 3 by a negative 1/2. Alright, so now this is a review on 6th grade again. Because I'm taking 3 and I'm dividing it by 1/2. So it looks like this. So I'm going to turn this 3 into a fraction. Someone raise your hand and tell me, remind me what your 6th grade teacher taught you about dividing fractions. I'll give you a hint. It's 3 letters. Cole. KCF. That's right. Most likely your teacher told you to keep the first fraction, change the second or the operation to a multiplication, and then flip the last fraction. So whenever I do that, it looks like this. 3 over 1 times 2 over 1. What is 2 times 3? 6. And then 1 times 1 equals 1. Therefore, I've got x equals 6. And the reason why is this was a negative 3 over 1, and that's a negative 1/2. When you divide a negative and a negative, you learn in 7th grade that that's going to equal a positive answer. Alright, so I've got x equals 6. So let me mark off a little room right here, because I gotta find out what y equals. Someone raise their hand and tell me, how am I going to find out what y equals now that I know x equals 2? Let's go to I think that's Siobhan up there. No, Jasmine. Very good. Which equation do you think would be easiest for me to use? Yes, I agree. So I'm going to use one of the original equations, y equals negative x, and I'm going to take 6, because that's what x equals, and I'm going to sub that in for x. So when I do that, my equation looks like this. Y equals negative 6. So there we go. There's my answers. I've got x is 6, and y is negative 6.